Hello everyone. In today's math tutorial, we want to show you 4 different ways to find a quadratic equation. So sit back, relax, and enjoy the tutorial. Number 1, from the roots of the quadratic equation. We will be showing this with this question. Find the quadratic equation whose roots are -1 and 2/3. So if the equation is in x, we can say x is -1 or x is 2/3, the root of the equation. We can write this as x equals to -1 or 3x equals to 2 when we multiply both sides of the second one by 3. Then adding 1 to both sides of the first one, we have x plus 1 equals to 0, or subtracting 2 from both sides of the second, we have 3x minus 2 equals to 0. Multiplying these two, we have x plus 1 multiplying 3x minus 2 being equal to 0. Then we expand the terms in the bracket to give 3x squared minus 2x, that is using x to multiply the second bracket. Then using +1, we have plus 3x minus 2 equals to 0. And this finally gives 3x squared plus x minus 2 equals to 0 as the required equation. Don't go yet, there are still many more to unfold. Number 2, from the sum of the roots and the product of the roots of the quadratic equation. We'll be taking this by looking at the question. The sum and product of the roots of the quadratic equation are -3/2 and -2/3. So we want to find the equation. But before we do that, if we let alpha and beta be the root of the quadratic equation, then by what we did earlier on, we have that x will be equal to alpha or x equals to beta. And from here, x minus alpha must be 0 or x minus beta is 0, which means that x minus alpha times x minus beta must be equal to 0. And that expands as x squared minus beta x minus alpha x plus alpha beta equals to 0. Rearranging by putting alpha first, it is x squared minus alpha x minus beta x plus alpha beta equals to 0. And combining the terms having x by factoring the negative sign and the x, we have x squared minus alpha plus beta times x being factored out plus alpha beta equals to 0. This is the form of quadratic equation where alpha plus beta gives the sum of the roots and alpha beta is the product of the roots of the equation. So the values given to us in this question, -3/2 and -2/3, we are going to substitute them into this form for the sum and product of quadratic roots. And this is going to give us the quadratic equation x squared minus then -3/2 x, which is the sum of the roots, plus -2/3, which is the product of the roots. And that's equal to 0. Simplifying further will give us x squared plus 3/2x minus 2/3 equals to 0. And when we multiply through by 6, which is the lowest common denominator of 2 and 3, the required equation will be 6x squared plus 9x minus 4 equals to 0. Number 3, when the vertex and any other point on the quadratic curve are known. Here we are given the vertex of a quadratic equation as -2, 5, and the vertex is given by h, k, which is -2, 5 in this case. And this curve passes through the point 1, 4. So we can say x, y is 1, minus 4 rather. But the vertex form of a quadratic equation is y equals to a into bracket x minus h all squared plus k. So substituting first the values of h and k into this equation, we have y equals to a into bracket x minus negative 2 all squared plus 5, which simplifies to y equals to a into bracket x plus 2 squared plus 5. Expanding the bracket on the right hand side, we have y equals to a into bracket x squared plus 4x plus 4, then plus 5. At this point, we are to substitute the values of x and y given in order to get the value of a, the leading coefficient. And that is going to give us minus 4, which is the value of y, equals to a to bracket 1 squared plus 4 times 1 plus 4, and then plus 5 outside the bracket. This becomes minus 4 is equal to a. Inside the bracket, we have 1 plus 4 plus 4, then plus 5. Subtracting 5 from both sides, we have minus 4 minus 5 is equal to 9a. 9 is the sum of all the numbers in the bracket. So we have minus 9 equals to 9a, and dividing both sides by 9, a is negative 1. Now that we have the leading coefficient and the vertex, we can substitute back into the vertex form to get the quadratic equation. So that we have y equals to minus 1 into bracket x minus minus 2 all squared plus 5, which becomes y equals to minus 1 times x plus 2 all squared plus 5. We can open up the bracket to have it in standard form. And that is y equals to minus 1 times x squared plus 4x plus 4 in the bracket, then plus 5 outside the bracket. So that it gives y equals to negative x squared minus 4x minus 4 plus 5. And finally, the quadratic equation is y equals to minus x squared minus 4x plus 1. If y is 0, then the quadratic equation is minus x squared minus 4x plus 1 equals to 0. Now, here comes the greatest of all. Adjust your seat and make sure you watch to the very end. Number 4, when we know 3 points on the curve. In this question, we have to find the quadratic equation that passes through the 3 points given. Now, note that the general form of a quadratic equation is given by y equals to ax squared plus bx plus c. So we are going to take the points one by one in order to get equations in a, b, and c, which we solve simultaneously in order to get the values of a, b, and c. So taking the first point, negative 2, 1, means that x1 is negative 2 and y1 is 1. When we substitute this, we have 1 equals to a times negative 2 squared plus b times negative 2 plus c, which becomes 1 is equal to 4a minus 2b plus c, or this can be written as 4a minus 2b plus c equals to 1. That is equation 1. The second point is 1, minus 5, which means x2 is 1 and y2 is negative 5. Substituting, we have 5 equals to a times 1 squared plus b times 1 plus c. Substituting to the general form, we have minus 5 is equal to a times 1 raised to the power 2 plus b times 1 plus c, which can be written as a plus b plus c equals to negative 5, and that is equation 2. Then the third point, we have x3 to the 3 and y3 to the 1. Substituting again, we have 1 equals to a times 3 squared plus b times 3 plus c, and this becomes 9a plus 3b plus c equals to 1. That is equation 3. So we solve equation 1, 2, and 3 simultaneously in order to obtain the values of the constants of the quadratic equations. And to do this, we will subtract equation 2 from equation 1. Equation 1 is 4a minus 2b plus c equals to 1, while equation 2 is a plus b plus c equals to minus 5. So subtracting, we give 3a minus 3b equals to 6. Dividing through by 3, we have a minus b equals to 2. We can call this equation 4. We subtract equation 1 from 3. Equation 3 is 9a plus 3b plus c equals to 1, while equation 1 is 4a minus 2b plus c equals to 1. Subtracting gives 5a plus 5b equals to 0. Dividing through by 5, a plus b is 0. This is equation 5. Now that we have successfully eliminated c, we can add equations 4 and 5. That is, a minus b equals to 2 in equation 4, and a plus b equals to 0. Adding them gives 2a equals to 2. Then a is 1. To get the value of b, we put a equals to 1 into any of equation 4 or 5. So into equation 5, we have that 1 plus b equals to 0, and b is going to be negative 1. Finally, we put a equals to 1 and b equals to minus 1 into equation 2. So that we have 1 plus minus 1 plus c equals to minus 5, as equation 2 is a plus b plus c equals to minus 5. Now we have 1 minus 1 plus c equals to minus 5, meaning that c is minus 5. Now that we have the values of the constants a, b, and c, we will substitute back into the general form of quadratic equations to get the required equation. The general form is ax squared plus bx plus c equals to 0. That is, we have x squared minus x minus 5 equals to 0 as the required equation. We believe you have learned the 4 different ways to find a quadratic equation by the roots, sums and products of roots, vertex and a point, and 3 points on the curve of the equation. If you enjoyed the video, give us a thumbs up by liking the video. Ensure you share it, leave your thoughts in the comment box, and subscribe to the channel. Ensure you hit the notification bell so that you can be notified when our next tutorial comes out. But for now, do enjoy your day. Bye.